Hi, it's Renata here. If it's your first time here, welcome to my channel, The Quanti Girl, where we are going to talk about some topics in quantitative finance, in pure and applied mathematics, in Python programming, and sometimes about music, because I'm a PhD in mathematics and a financial quantitative analyst that is also a violinist, and I'm here to share with you some of my experience. Today, we are going to code in Python the Travelling Salesman Problem, so just keep watching the video and we are going to code it together. Before we start coding, let's talk a little about what is the problem. The traveling salesman problem is a classic optimization problem where the goal is to find the shortest possible route that visits a set of cities and returns to the original city. There are various approaches to solving the traveling salesman problem, and one common method is to use a brute force algorithm or a more efficient heuristic algorithm like the nearest neighbors algorithm or the genetic algorithm. The method we are going to use today to code the problem in Python is a brute force approach, but we need to observe that this approach is not efficient for a large number of series due to its factorial time complexity. In some video in the future, I will code the problem again and compare the computational time with the brute force approach that we will use today. So now let's start coding. As we talked before, we are going to use here the brute force approach. So the first thing that I need to do is to import the libraries that we are going to use. So the only library that we are going to use today for this problem is the library itertools, and more specifically we are going to use the function permutations. So now let's build a function to calculate the distance between two series. So let's name it as calculate distance. So the function will have two parameters, which are the two series that we wanted to know the distance between them. So we can assume here that the two parameters of the function, series 1 and series 2, are represented by x, y coordinates. Let's just comment this. And now let's finally write the code that uh, compute the distance from between the two series. So we are going to take the difference between the two series and squared the difference and now take the second distance of the other coordinate. So again we square the distance, the difference, and finally we multiply by 0.5. So okay, um, okay, I forgot the minus signal here, and I think it's okay now. Yeah, so let's move on. And now, okay, here we built this function to calculate the distance between two series, and now we are going to build a function to calculate the total distance for the route that we take between the series. So let's call this function total distance. And the parameters of this function are the, the path, let's call it route, and the series that compose the route. So let's initialize the distance as 0, and now we need to iterate for all the route. So let's take an iterator I, and we are going to iterate in the range from 0 to the length of the route that we are taking. Okay, now what you need to do is to update the distance for each iteration. So we are going to add a quantity to the distance that equals now we are going to use the function we built here to take the distance between the series that compose the root and to sum them. So let's call the function calculate distance. Okay. So we need to take the series. If you are in the iteration I, we need to take the series of the root I and I plus 1 and compute the distance between them. So let's write it. So first, the series 1 in the root, the series I in the root. Remember that the root is the parameter of the function that we are building here. So the other series is the series I plus 1 of the root. Okay. Now we need to update the distance, this distance here. Okay, first we initialized the distance as 0 just to begin to run the iterations. Then we calculated the distance between series I, if you are at iteration I, and the series I plus 1. So now let's update the distance. So what we need here is the last series in the root, the last series in this root after we calculated the distance between the two series in the iteration. So now we need the distance or between the last series and the first series. So this is the last series, and we are updating the distance of the path, the total path. So what we need here, actually it is, the root is inside the series parameter. And what we need here after the comma is the first series. So with this, we update the distance of the total distance of the route that we are taking after we calculate the distance between the series in each iteration. So now we need to return in the total distance. So the variable here that we are denoting by distance, and let's see if it's working. Yeah, okay, so let's move on. And now it's the final part where we really apply the brute force algorithm to find the shortest path between the series using the total distance function that we built here. So let's define our last function. Let's call it the function Travelling Salesman Brute Force. And the parameters are the series that compose the path, the route. So let's define a variable to take the number of series in the route. So let's call it num series, and it is the number of series. So the length of the series parameter. Okay, so what the algorithm need to do here is to generate all possible routes between the series in order to find looking to all the possible routes to find which one has the shortest path. So let's do it, generate all possible routes for the series. So let's create a variable called all routes, and to build all the combinations, all the possible combinations, we are going to use the function permutations from the iter_tools library. And what we are permutating here are the series. So the parameter here is the range between 0 and the number of a series of the path. So now what we need to do is to store the best route and its distance for the set of series that is the parameter of the function. So one way of doing this is to initialize variables, is to initialize a variable to store the best route, and also to store in another variable to store uh, its distance. So uh, let's create two variables here. One to store the best route. We need to initialize the variable. Let's initialize it as non-type. And now a variable to store the route's distance. So let's call it mean distance and initialize it as float type. So now what we need to do now is to iterate through all routes, through all possible routes, and calculate its distance. So, okay, let's comment it just to be clear what we are doing here. Okay, so we need to iterate each route for all the possible routes that we are denoting here by all routes. So first we need to calculate the distance for this route, the total distance for this route using the function total distance that we defined previously. So this distance is the total distance for this route. Now we need to compare this distance with the mean distance to know if we already reached the minimal distance between the series of the route, or if the algorithm needs to continue to search for the minimal distance. So let's create a condition here to take this. So if this distance for this route is less than the minimal distance, that we define here, and we initialize it as float. So if the distance is less than the minimal distance, then the minimal distance is the mean distance and the best route is this route of the present iteration, because it's the mean distance. Otherwise, the algorithm continues until he finds the minimal distance, until he finds the route that hits the total minimal distance. So, okay, now we need to return the best route and the minimal distance. Okay, let's test if our algorithm is working. Okay, let's take an example here. Remember that we are specifying series as x, y coordinates. So let's fix an example here. So let's take a set of a series here. We can keep things very simple here. So the first series, we can take it as being 0, 0. The second series as 1, 2. The third one as 2, 4. And the last one as 3 and 1. And now Let's apply our function traveling salesman brute force to this series here to calculate by brute force the best path between the series, the route that has the minimum total distance. Okay, let's print the results. Let's check if it's working. Okay, okay, we need to fix uh, this line of code here, and let's run everything again. Okay, now it's okay. So for this set of series here that we specified here as an example, just to fix ideas and to see the algorithm working. So for this set of series, we applied our function traveling salesman brute force that computes the path, that takes the path that has the minimal distance between the series using the brute force algorithm. For this set of series, we have that the best route is this route here, and its minimal distance, that is the distance of the best route, is this number here. This code defines a simple brute force solution for the traveling salesman problem. It calculates the total distance for each possible route and keeps track of the best route and its distance. But as I mentioned before, keep in mind that this approach becomes impractical for a large number of series because the number of possible routes grows factorially. That's all for today. Hope you like the video. Don't forget to hit the like button because it helps me a lot. And also, don't forget to subscribe to the channel so you can know when I upload the next videos. See you guys in the next video. Bye!